Okay, so here again, we have a bit of an issue in that these bases aren't the same. I can maybe express 512 as a base 4 number, but again, we still have this issue that 8 and base 4 don't match. However, they do have a related base of base 2. And if they have a related base, we can just use exponent rules here to make them equivalent bases. So I'm going to do that. I'm going to go 2 to the power 3 to the power x minus 2. I'm going to express, this has to all be base 2s to do anything with it. We need one base 2 on the left side, we need one base 2 on the right side. So the 512 I'm going to change to 2 to the power 9. Okay, and then this becomes 2 to the power 2 to the power x. That's 4 to the power x. And then I'm going to simplify this. So it becomes 2, 3x minus 6. 2 to the power, that's going to be 2x. And then we're going to add on 9 multiplied by 2 9 times. So it's going to be plus 9. Again, now we have one base 2 equaling one base 2 over here. That means that this exponent and this exponent have to be the same for this to be equal to each other. I can then rewrite the equation to solve for x. I get 2x plus 9, so I end up with 1x on this side and then 15 on this side. So there's my answer for x. So I'm undoing the exponent by being able to express this as a common base and then making the exponents equal. So same thing here. This one, although it's 1 over a, that is still a power of a. Okay, so I can rewrite 1 over a as a to the negative 1 to the power 3x. And then we're going to end up with a to the negative 3x. Again, the exponent, the bases match. We have an equation, so the exponents have to match. Okay, so we end up with x minus 2 equals negative 3x. That gives us 4x on this side, positive 2 on this side. X equals 1/2. Okay, so there we go. There we have a way we can undo these exponents without necessarily guessing. We kind of guessed up here. Okay, we did these easier ones by guessing, but when we couldn't guess, we can use this strategy of making the bases the same and trying to equate the exponents. Okay, so when we look at this problem here, there's a bit of an issue. The issue is we can't use divisibility because powers and divisibility are different. Although 5 and 100 have a common factor of 5, we can't use divisibility because this is to do with powers. Okay, they don't follow the same math. We have to be able to express this number with the same base as that number. And that's not possible. Okay, we do know that 5 to the power 2 equals 25, and 5 to the power 3 equals 125. So the only thing we can kind of say is that, well, if 5 to the power 3 equals 125, 5 to the power 2 equals 25, then the 100 must be somewhere in between. It's got to be somewhere in between, less than 125, bigger than 25. So this x must be somewhere between the 2 and 3. We don't know. Okay, it could be, 2.5. We're not sure. We can kind of guess, though. We can guess and test, right? So I'm just going to guess x is equal to 2.5, and I'm going to just test it in my calculator to see how close I was. 5 to the power 2.5. I'm getting 55, so that's not very close. So I'm going to try another one. I'm going to guess a little bit higher because I want a number closer to 100. So this is 5 to the power 2.5 equals about 55.9. I'm going to guess x is equal to 2.8. Okay, and I can just keep on going like that, and it's just kind of guessing. And if I have no other strategy, guessing kind of is my only strategy that I have. So I'm getting about 90.6 here. Okay, 5 to the power 2.8 is about 90.6. So maybe it's a little bit bigger. I'm going to guess 2.9. and I'm probably going to get a little bit closer is my guess. Okay, so trying 2.9, I get over, so I'm too high. So I know I'm somewhere between 2.8 and 2.9. So if I were to, at this point, I have an even better guess. Based on all of this information, I'm going to just say, well, x is about 2.85 maybe, right? I know it's got to be bigger than 8.8 because that's going to give me 90.6. It's got to be less than 2.9 because it's going to be 106.4. Okay, so we can't, that's about as good as we're going to get. We can just keep on going more and more and more by just get better and better guesses. Okay, but I think we need a different strategy here. Okay, so what was the difficulty? Well, the difficulty is the two numbers cannot be expressed with a common base. Okay, so the numbers cannot be expressed with a common base very easily. Okay, very easily. Okay, so we probably want something a little bit better than this, and something that we can use.